going to look at some of the fundamental construction basics on how to detail a window, or for that case, most types of openings as well. Of course, there are very many different ways on how you can detail those, really depending on the type of material that you're using for your for your load-bearing structure, for instance, or the material that you're using for the facade as well. And then, of course, it also depends on what kind of windows, what types of windows are available to you in a specific country or a specific location that you are building this type of house, or most importantly as well, what type of architectural expression that you are aiming for, of course. So these all have a big influence on the detailing, but nonetheless there are certain or basic principles in the construction that are really important for all of them. So overall, and I'm just trying to get my pen out here as well, your window will be part of the insulation layer. So what we can see here is on the outside, the insulation, and your window together with the window frame and the glass will be part of that layer, because both of these parts, the frame and the glass itself, will have certain insulating properties. So, and as we know, to prevent any kind of thermal gaps or thermal bridges, we want to have that insulation layer continuous. In this case, because it's more like a principal detail, not a really specific one, it's solved in a quite easy way. But of course, if your window frame would be sitting somewhere back here, you would have to make sure that that insulation is continuous. So it'll be continuing to the window frame and then to the glass and all of that. So that's one of the basic principles to keep in mind of. And then the other one, your window is not just part of the insulation layer, but it sort of becomes part of the load-bearing layer as well, because it is kind of like, preventing, if someone is in here, that they are not falling out as well. So if any kind of pressure is put on the window, whether that's physically from the inside or, for instance, the wind pressure from the outside, we want to make sure that that window is fixed securely to the load-bearing layer. Therefore, when we zoom in here a little bit, your window frame will need to be attached in some way to the load-bearing layer, which now here is shown as these concrete walls. And that kind of assembly will happen all around that window frame, so also on the top. So with most of these things that we are addressing here, they will be crucial to solve on the bottom of the window, and in a similar way it will happen at the top of your window frame as well. If we zoom in a little bit closer as well on that window frame, or the window in general, there's heaps of different parts that we can identify. I'm just quickly going to point out the most important ones, and we do have a slightly more detailed drawing here, which is roughly a 1:5 detail of a kind of standard detail. So any type of window consists of a frame, which then is made up of the outer frame, which again is fixed to the load-bearing layer, and then some of them, not all, but most of them do have a sash frame as well, which is the one that's movable, that you can open. Of course, there are fixed type of windows as well that you can't open, and in that case, these two frames are kind of merged together and they become one, and the glass will be immediately connected to that outer frame directly. That's a possibility as well, but we are now looking at these kind of openable windows. The glass itself is that kind of object will be manufactured in one piece, so the glass will be attached to the frame, to the window frame as well, and it will actually be inserted into that frame. As you can see, that piece here is a continuous piece made out of one material. Probably in this specific case, it could be a timber window. The glass is then inserted and it is held in place with this little movable or removable piece, which is a glazing bead. So these are kind of the main the most important elements that we will find in a window frame. So going back to the slightly bigger scale here as well again. The window as part of the insulation layer means that we do have certain requirements on the thermal performance of that window. So on the one hand, our window frame needs to be insulated in some way. If that is made out of a timber product, then the timber itself has a well enough insulating properties. And then the second part is obviously the window itself, the glass. And in general, glass by itself is not really a very good insulator. So that means that's why single glazed windows are actually performing really poorly in terms of thermal performance. And we do aim to have double glazing, or even better, triple glazing that is installed in our buildings, because it is not the glass itself that is providing the insulation, but it's actually the gap in between, which can consist of dry air, or even better, consists of a gas which has slightly better thermal qualities, such as argon, which is very often used in between the window, in between the glass panes. So argon is an odorless, colorless gas which is non-toxic. So it'll be trapped in between those sheets of glass and therefore providing the insulation. Of course, insulation is not just important in terms of thermal performance, but also noise reduction, noise insulation. In cases where there might be a really noisy outside source, as indicated here by the number 3, could be a motorway, or maybe some kind of industry that's located nearby in your neighborhood. And in that case, you want to protect the people living or working in your building by making sure that these windows have a certain noise reduction as well, noise insulation. If that outside source is really, really bad, sometimes we have to revert to an idea of having windows that cannot be opened. So the window will then perform solely as a visual connection to the outside and as a solar gain and all of that, but you might not be able to use it for ventilation. So you can't open it just as a measure to protect the people inside from excessive noise. That means that we will then need mechanical ventilation rather than a kind of natural ventilation by opening the windows. A really important detail, of course, when talking about windows is protection from the sun. Here we have an external shading device. The most efficient shading devices are located on the outside, on the exterior, because what happens here, if we have heat rays, it's not just the visible light, but of course it's the heat rays that we want to keep outside. So on the one hand, we are protected from glare and excessive sunlight and UV light as well, that's coming on the inside. And these heat rays are then reflected and kept outside. The problem with having internal sun protection, such as a curtain or some kind of louvers that are on the inside, is that those heat rays will then penetrate the glass, which is on that layer here, and they are now trapped inside. They can actually bounce on and off in between that curtain and the glass as well. Therefore, they are heating up that air. And of course, that kind of gap between the curtain and the glass, that's not isolated from the rest of the room. So if the air inside here is heating up, it will eventually mix with the air of the rest of the room and therefore heat up your entire room, which in summertime can be very uncomfortable and that we want to avoid. Of course, we do want to have some solar gains in winter time, so we don't have to heat as much on the inside with like mechanical heating or these sort of things. So in that case, having a flexible element on the outside that you can adjust depending on the temperature, depending on the physical comfort needs of the people inside, is really helpful. Of course, there are also fixed external shading devices, such as sometimes we can see these brise-soleil, like little overhanging structures above a window, and they are usually designed in a certain way that they allow the winter sun, which is usually at the lower angle, that they allow them to penetrate the window to actually to have solar gains. And then we have such when the summer sun, which has a higher angle, they actually block that kind of sun, making sure that it is efficient in both winter and summertime. So these are some basic different principles on how we can apply them. One of the things with any type of external sun shading that we have to think about as well, especially with buildings that are multiple stories, is that these might be slightly fragile in terms of high wind speeds and all of that. So sometimes especially with office buildings that might not be always occupied, or there might not be a single person responsible for the safety of these elements, what happens is that they have a little sensor somewhere on the building, like a little wind wheel thingy that measures the wind speeds, and as soon as the wind crosses a certain threshold, these external shading devices will actually close, or they will roll up, just as a way to protect these elements so that they are not getting damaged through heavy winds. So that's one thing to keep in mind as well. Then, of course, with any detail, one of the most important things is always protection from water. And with the window, of course, we have rain that is with any type of material on the envelope, it's always going to be exposed to rain or hail or any other kind of element. So when we have a closer look at the window frame again, what we can see here is that on the one hand we do have a windowsill on this side, and then there's a small what is it called, a weather bank as well. So these kind of gaps that are naturally, we can see them here, that are present because we are actually merging two materials. So we have the windowsill and the frame. So there's a tiny little crack or a crevice here that needs to be protected. So making sure that none of the water is seeping in here and potentially damaging both the frame or the insulation. So that's usually part of that system, part of that window element that you are choosing to use in your construction. They usually come together, so to speak, but you definitely have creative agency in how they are designed. With the windowsills, here we can see more like a metal sheet that's bent into place, and if we zoom out a little bit or we have a closer look at it, one of the most important things is that it's actually laid to fall. So there's a tiny little bit of a slope, so making sure that the water is actually flowing away from the window and it's not sitting in here and potentially starting to seep in. And another thing that we notice is that kind of rain water drip. So if it's just a simple metal, or if it's even shaped like this, as you know, when you have, let me get a bluish pen for a little raindrop. If rain is coming down here, and sometimes it has that capillary effect, and sometimes the rainwater seeps in, and if we have wind blowing from the outside, it might actually push that water inside the construction. So again, that is, pardon me, that is that detail here. So if you do have raindrops, they can suddenly be pushed into the construction. So that's why we have these rain drips. If you have a different kind of windowsill, such as sometimes you see these stone elements, for instance, again, you would have a slight incline, making sure the water is going away, and then a little rain drip. So if the water is seeping in, it is then dropping off here. The facade would probably be somewhere on that layer. So you have a little bit of a distance between that very controlled raindrop that's coming down and the actual envelope, therefore making sure that your facade material is not just getting completely soaked up, and you have, on the one hand, it can lead to damage, or it ages much faster. You could have algae grow there because it's always moist, but it's also an aesthetical thing, because all of a sudden your facade is always could be wet, and it looks different or not very nice. So water management, one of the most important things to keep in mind. Also to keep in mind, in combination with that, is how the window is then meeting the facade material here. If you have a facade or a material such as a timber facade or something that requires an air cavity behind it, in between the insulation, you want to make sure that that air has space to escape, and therefore the windowsill and there's a tiny little gap between the windowsill and the facade material there as well. So that's one thing to keep in mind. And just to quickly go back to the slightly more bigger detail again, we can see that here, that one would be the exterior, interior here. We see that weather bank, depending on your manufacturer, they always look a bit different. This one is a metal piece that's bent into shape, and then here only partly we can see it. That's the windowsill. Here it's a solid material, and again that weather bank is actually protecting rainwater or any other kind of thing to seep in. There's an additional sealant in between the frame and the windowsill as well, making sure that it is properly sealed off, but also giving it a bit of a tolerance, as you can see here. So these type of materials, they are not completely flush, because as you know, not everything can be manufactured or assembled on a site as precisely as you were to draw it in a detail. So you have to consider these kind of moments where things might not match properly, and you have these little tolerance gaps in it as well. So yes, I think these are some of the most important, just zooming out here again, some of the most important things to consider when detailing windows. And as I've mentioned before in the beginning, each of those details, they will look slightly different. Here in that principle, again, we have the window in the middle of the construction. Your window could just as likely be sitting flush on the inside, or it could be sitting flush on the outside. And all of this, of course, has an impact on how these details are drawn. We will have a look at some of these more specific solutions in other videos. You're more than welcome to request any of those videos as well. If you have a specific question, or you know a reference building that you're keen to learn more about, to understand how it was built, I am more than happy to have a look at that as well. So this page, as well as the other one that I have shown here with the more close-up, they are both from the book Constructing Architecture, which was edited by Deplazes. It's a really, really good resource for any architect, especially for architecture students. I will put all the details about it in the description box below, so you can check it out. Hopefully your library will have a copy of it. If not, I would highly recommend having a look at it and potentially add it to your own collection. So yes, let me know if you have any more questions. Happy to answer those for you. Thank you.